So this time round we talk spell sign window. And before anything else, I think that we just prep log. So spell um, sliding window. Obviously, you always argue a certain spell brute force conditions that we have for the after. Which is for my spell obviously, and before for I think Leetcode question specific. One thing for sure, question specific is that the condition is that only time can kind of like travel forward. So time travel forward, that's question specific, because I mean for time for this one is because it's like stocks, and then you can't travel back time. The time will always be forward, right? So you can't play with numbers by saying that you want to go reverse, right? So and if we dive deep, I think is to do with this calculation, which is b minus a is equals to your sort of your answer. So that is another condition set for question specific. You b minus a equals to c, and your this c is actually your final results, right? So maybe say equals result, right? R stands for the results. So what we do here is from the very get-go, I think we straight away establish already, straight away say that okay, my L and the R, and obviously we want to have the highest of like amount, so therefore we do max profit, right? We want the highest, so obviously we have a data to actually store that say that okay, to actually read for us, okay, keep on storing like the highest data. This is actually very very common for most SQL question, is that you have a data stored to actually record down what's your highest data, and usually this one is usually just store one data. So I believe when you put into computer, it's fairly simple. So yeah, so we just continue play out. Let's play out to find some inspiration. So obviously LR, we start here. You go back to your formula, you do the ops, right? So maybe say op z is having our b minus a equals our sort of results. So obviously this one, you 1 minus 7, you get negative result. Really bad, right? Really bad. And now the question is like intuitively you're not going to use it, and then now the question is where do you want to start? Where do you want to start your L over here? So obviously intuitively speaking, you want to start at the lower range, right? So obviously you remove the L, you plant it over here, you shift everything over towards the right side, and then now you start to do the Z operation again, and then this time round you get I think this is a 5 minus 1 per se, and that gives you a 4. So that give you a new max profit 4. Fine. And we start calculate again. Say that our R runs here this time around, and this time around we get a 2. Don't really have like a max profit. That's like 2 isn't bigger than 4, so we kind of continue, because the thing is we are actually very satisfied with our L because it's the lowest point. So I mean, if we were to see the Z operation, is that you want your A value, right, to be as low as possible. And from the chart, we do see that here A is actually one of like the lowest. We want we can settle down our A to be here for the most parts already. So we move over here. I think it's 6. So you 6 minus 5, 6 minus 1, you get 5. So now this time around you got like a new value. You have a 5 over here. So that's great, right? That's great. And then we try to move on again. We try to see the last data. It's 4 minus 1, 3, not bigger than 5. So we have like our final result sent back to the computer, sent back to the system already, and pretty much it. So then they say what we see in the grand scheme of things is that we use a lot to do with say intuition, I'll say, right? For this one, we first up we see the graph in a general grand scheme of things. We basically intuitively tell ourselves where do we want to plant our A, right? We can tell where should we plant A, where should we plant a B. For the Z operation, it's definitely this A value we want to be as low as possible, and for the B value we want as high as possible. So intuitively speaking, when we drew out the graph, is that here is one of the lowest point, and the highest point is at the left side and the right side. But the thing is, we have the rule for question specific is that time only travel forward, so we don't have the option to pick the left one, we only can pick the right one. So therefore we got no choice but to plant the B over here, which eventually do get our result. With 6 minus 1 get a 5, which is our final result per se. So in terms of like mechanics wise, what we use, we did somewhat two pointer. I wouldn't really argue say that this is a sliding window. Like, this is the tricky part. I would actually argue that this one is actually using maybe say 2 pointer, and having like a condition set that you move your L with a condition of saying that we want the lowest value and the highest value. So for each of them, so I think it's based on question specific. So my L has to be as low as possible, and my R has to be as high as possible. So in a way, it does correspond with time moving forward, right? Because your L, because you can't put your R, you can't put your L to be high, because you can't travel back up. So if you go see intuitively speaking, is that if time always travels towards the right, your left data usually must be as low as possible, your right must be stretched up as high as possible. So I think this corresponds very well with time moving forward. And having this property, I just feel that we are kind of like using the condition set for in terms of like for our proper for our spell casting of two pointer to have our left as the condition of being as low as possible and our right to be as high as possible. And then after that is so much more about the aftermath. So they're gonna do the bring after we get this data over here, we calculate maybe say this is the y operation. Y operation, it tells us like the aftermath of z, because z is at the one that's do the calculation. So if b minus a equals the result, and this resulting brings us to the y condition. We store inside this box saying that, oh, how much which one is like the biggest profit, which one is the biggest number, because at the end of the day we want the biggest number. We do the z and the y operation to get the highest value. And by having our two pointer to maneuver around the map with the condition set of saying that L must be as low as possible, R must be as high as possible as we move around the map over here. So that's the condition set. And then and obviously you can actually argue brute force, right? So every time you always can brute force your way through. So say for example, this is your first point and this is your second point. You calculate, and then you calculate this, you calculate this, you calculate this, you calculate this. So by mean this, that means you execute the z operation for all this pattern, and then this pattern 1, then you go on to pattern 2 obviously, and calculate this, and then you come back to the third point, calculate this. This is basically brute force. Obviously you do see that you doing this operation, maybe call this operation A per se, and doing our two pointer is so much more about like the B operation. Obviously if you argue A operation, obviously you can see obvious that it manipulates all the different forms of pattern, so it's BON square. But for B itself, it's definitely just a two pointer moving across the map, so it's just big O of n. So that is the argument between these two pointer and the brute force method, right? I think when it comes to like you arguing between brute force and two pointer, it's usually this case that you always argue back into like the big O time complexity of how much it takes. It's usually this one. So yeah, with that everything comes to an end.